Okay, so welcome back guys to another Minecraft video. In today's video, I'll be showing you how to create a fully working FNAF AI system. This system will let you be able to customize your animatronics, obviously from 1 to 20, or however many levels you want in your game. So without further ado, let's get started. So the first thing you may notice is that the thing I'm standing on right here, this is our a random number generator that I have made. It's a pretty reliable system. Well, it's actually a very reliable system. And inside our dispenser here, you can see we have 5 bits of paper, numbered 1 through 5. These, well, for my example here, I'm going to be using these 5 levels to essentially represent our animatronic's difficulty. Speaking of our animatronic, here he is right now, Mr. Test. He will be our animatronic that I'll be using to move around the building. And obviously, we have this command block here, which very simply sets this block right here to a redstone block. This command block right here will then set this block back to air, so the system can trigger multiple times. Now, one of these systems can usually hold up to 10 pieces of paper because you have the 9 slots in the dispenser here and the first slot in the hopper. But obviously, if you want to have a system up to 20, you'll have to build, well, 3 of these. You need one for holding 1 to 10, one for holding 1 to 20, and then one to basically decide which of the two systems it's going to trigger. So, the first thing we're going to want to do, we're going to want to place down our command block here, and then we want to do test for at e name equals 1. Set to always active. Throw down a comparator. And then you want to do scoreboard. Spell it right, there we go. Scoreboard players set number if no 1. Very simply, well, do right as it says on the tin. It will set the scoreboard value on my right to 1. And then you'll want another command block here, setting the scoreboard value back to 0 so we can reset the system. Not at e, number, no 0. So if the number 1 is thrown out of this, you can see the value is now 1 and now it's set back to 0. Now the next thing you'll want to do is clone this system for however many levels your game has. So for my example here, there are 5 levels in total, meaning I'll have to clone this 4 times, and it will test for the other numbers in the dispenser right there. So I'll be right back once I have done that. Now, as you can see, our system is working just fine. Whatever number is being pulled out of the dispenser is the scoreboard value on my right that is being set from numbers 1 to 5, and then that number will be set back to 0, so the entire system can reset. So the next thing you'll want to do, now that we have the thing here done, you're going to want to type in scoreboard. No, not scoreboard, not scoreboard yet. I screw this up every time. Execute as at e scores equals diff lev equals 1. Run, and then you want to put scoreboard, if I could spell it correctly again. Players test number if no 1. So difflev represents the difficulty level of the animatronic, and diffno, obviously, as you've seen, is the number that is being pulled out of the RNG generator. Well, I said random number generator, the machine right here. You know what I mean? Yes, this system will basically test if the difficulty level of our animatronic in there is at level 1, and it will test for the scoreboard value of diffno to be 1 and only 1, so I need to put a second 1 in here. Then this command block is going to scoreboard players add at e. Then we want this and this. Scores equals difflev, excuse me, difflev equals 1. Move no 1. The move node represents obviously the move number of the animatronic, so it will add 1 to the value of him if his difficulty level is 1, which it's currently set to 5, so that won't do anything. So again, like this system, you'll want to clone this for however many levels you have in your game. So again, I have to clone this 4 times, and I'll be back once I have done that. Something else to note when I'm cloning this system is you're always going to want to change the second number of whatever value you're testing for to the same number as your your difficulty level for your animatronic. So right here in this example, my diff level equals 5. So I'm going to want to test for the score for diff no to be anywhere between 1 and 5, which for my example would be, well, the minimum to the maximum. So yeah. So just remember to change those to whatever value is your difficulty level. Now that we have this system cloned, it's time to actually make our movement route for our animatronic. So you'll want to do scoreboard, again if I can spell it correctly, players test at E, and then the name of your animatronic. So in my case, it's going to be name equals test, move no, 0, 0, and chuck down a comparator. And the 0 will essentially be your animatronic's starting position. So in my case, it is 10, negative 60, negative 9, facing 11, negative 60, negative 9. So let's just throw that into our command block, our second command block here. 10, negative 60, negative 9, facing 11, negative 60, negative 9. That will essentially teleport our animatronic here to its starting position. You're going to want to clone this system for however many movements you want your animatronic to have. So in my case, there's going to be 3 movements. So that's 1, well that's 0 rather, and this is 1, this is 2, and this is 3. And 3, or the highest number value is always going to be the jump scare one. Whatever is your highest number value, so for my case it'll be 3, is the one where your animatronic is going to jump scare the player or gets deflected by the doors. So I will be right back once I've cloned and filled in all those move node values. Okay, so now I have my last movement number. Now obviously you don't want the animatronic to go straight into the office because otherwise what will be the point in actually playing the game. So what you want to do is you want to break this command block, place down a redstone repeater, place down a piece of redstone dust going out of that repeater, break this block that's in front of the redstone dust, and place 2 redstone dust going this and this. So one going into the hole and one going out to the side. I'll place a redstone repeater at the front, place down a redstone block, and then make not redstone block, a command block. And then you're going to want to set your animatronic's move node value to 0. Essentially means you've told it to go away. It won't jump scare you if the door is closed. Now this is only for door animatronics. If your animatronic is on the camera, well, that'll be a separate video for another time. But this example is only for door animatronics. Now obviously, this is going to be your jump scare block. So we'll have to teleport it to its last value, which will be 12, negative 2. And then after I've filled that command block in, I'll show you how to essentially stop the animatronic from jump scaring you. So you filled in the jump scare command block, and you've made your system to essentially dictate if the animatronic will jump scare you or not. So you're going to want to set block. You're going to want to place the block here to block the redstone signal from reaching this command block, and instead make it trigger this command block. So you want to grab the coordinate of your block. So in my case, it will be 33, 60, and negative 4. Then you're going to want to come over here to where your door system is. In my case, it's right here. On this side, you're going to want to do set block 33, and negative 60, and negative 4 to dirt, or any solid block. I just pick dirt because it's the easiest one, or the simplest one. And then on the other side, you're going to want to set block, put the same coordinates in, and you want to set a block to air, just so when the doors open, your animatronic can jump scare you. So currently it's now set to air, so flick the lever down, door is closed. and the block is now dirt. Flick the lever up, door is now open, block is air. So you've successfully done all that correctly, and now your animatronic should be deflected by the door. So all that's left to do now is test if the system works. So we're going to use test over here. His difficulty level is currently the max, so it's currently 5. So we're going to flick this to day. We're going to make this into a daylight sensor. I'm pretty sure that I should make it a bit slower than that, so let's set that to 150 ticks. I've only set that to 30 just to test if the thing works. I also should have made these into always active blocks as well. I forgot to do that. So let's just set his move node to 0. Right. And now once the system triggers, he'll move to his next movement position. Currently, he has a guaranteed movement chance. So now he's at the office. So let's close the door. And if you've heard that move, that means he's now back at his starting point. And now if we just let him move again, we let him into the office this time. He'll just stay there. And, well, technically, I'll count as a death because it will count as a jump scare. So let's just let him into our office. And as you can see, the numbers on the side, they're also triggering. And then we'll just close the door anyway. I just tell him to leave, even though he's already jump scared me. But because his AR level is 5, anything that is lower than 5, or lower than or equal to 5, will cause him to move. Obviously, if the movement is lower, then he'll have less of a chance to move. And again, however many levels you have, if his diff level is currently 1 and your max level is like 20, then he's going to be really slow. So there you have it, guys. That is how you make a working FNAF AI system with all full customizability in Minecraft. Now, obviously, I didn't actually put a customized thing in here, but all you have to do is just a block that adds 1 to his level and another block that takes 1 away from his level. So if I wanted to do that very quickly, I could. It just sets his level to either 1 more or 1 less than his current level, if that makes sense. So thank you very much for watching this video, and I do hope you found it useful. If you did, please make sure to leave a like and subscribe to the channel. If this video gets enough likes, then maybe I'll do one for camera animatronics, the ones that involve you needing to look at the cameras to deter them from moving. So thank you very much for watching, and I'll see you guys next time.